Oh, right. So for the last section in configuring Bazel, let's dig a little bit more into build files. So I said that most of the time you want them to be generated for you. What happens when you need to edit them by hand? How can you be more effective doing that? So this section, manual using rules in build files. So first of all, you may want to try to set up your editor to help you out. At least you should expect to have syntax highlighting inside of a build file. Even on GitHub, if you're editing there or viewing sources, the .bazel extension is registered as a Starlark language, and it does have syntax highlighting. Of course, there are other features you would love to have in your editor. So like jump to definition, auto completion, underlining mistakes, and being able to build or execute a target in place. You'll find there are some extensions for editors that are able to do some of those things. In general, what we want is something called a language service, which is a way that editors and languages can have a layer of indirection between them. So if we had a good Starlark language service, all the editors would work at once. There is one of these for Buck 2, and it's written in Rust. And in theory, that should be possible for that to work with Bazel as well, because Bazel and Buck both use the same Starlark language for their files. So watch for that at some point in the future as we make progress on that. Now, I mentioned that the build file has these attributes and they look kind of like Python. That's a language called Starlark that's Pythonish. The reason is actually that at Google, build files were originally actually written in Python, and then they realized that that gave you too much ability to mix declarative and imperative code. So they made a new language to pare that down and give incredibly good behavior. So parallel evaluation and read-only data structures so that you don't have mutable global state. You can read the spec for Starlark if you're interested more about why they made a language. It's pretty cool. And there are other tools other than Bazel that use it. So Copybara, for example, is a tool I use to copy code from a mono repo out into a separate repo, uses Starlark as its configuration language. There are two different types of files in Bazel. The build files that we've been using have a restricted subset of Starlark. So for example, you can't write a for loop. A .bzl file is meant for writing macros and rules. We'll look at that in the Bazel 202 course. And that uses the full Starlark language. So there's just a couple of things to point out that you will see in build files to be aware of. The first is load statements. So most of our build files will start with a load. In our example where we used sh binary and sh library, technically that should have been a load statement there. Load statements bring scope symbols into the file scope. So if I do this load statement, then whatever the second, third, fourth, and so on arguments are here are going to be symbols that I can then refer to later in my file. So write source files, for example, it's like an import statement. Important note is that Bazel is generally lazy about doing things. It does the minimum amount of work for what you ask for. Load statements, at least as of Bazel 8, are eagerly evaluated transitively. And so you will spend a lot of time in Bazel's loading phase if the load statements at the top of your file spider out into too many places. We'll get into more details about that in a later course. Also, quick note about load statements is you can alias the import, so you can rename it. That's especially required if, let's say, in this case, I'm importing something called bin. If you loaded several different Starlark files, each of which had a bin symbol, they would collide, so you're forced to rename it. Sometimes a rename is just good for comprehension. The other thing you'll sometimes see in a build file is a package statement. That's just basically setting defaults for all of the targets in that package. The most common one you'll see is visibility, which is going to be required to allow targets in one package to use targets in another package, basically prevent a dependency spaghetti from happening in your monorepo. And so you'll often have, if a build file, a package declares a bunch of targets that are meant to be usable anywhere in the repo, you would have something like default visibility public like this, so you don't have to repeat it. The last thing I'll mention is the glob function, which you'll see in build files. It's very convenient to be able to skip listing individual files like glob star.ts here. It also means when you add a new file, it's automatically included in the Bazel build without having to edit the build file. But glob does get evaluated all the time. And so in a really big repo with a big recursive glob, you will spend time on every Bazel run evaluating it. So you'll see that if you use build file generators, they will usually list out all of the files and avoid using glob. The other foot gun with glob, of course, is that packages are encapsulated. So if you create a new build file in a subfolder, that may have the effect of removing files in that folder from being part of a glob that they were previously part of because those files were part of a parent packet. So keep that in mind. If you're really interested in glob, there was an interesting talk this year at BazelCon that I point you to here.